Hi, this is lesson 8.2, graph simple rational functions. Our goals here, first of all, is to graph basic rational functions, including drawing the asymptotes. Second thing, describe the domain and range for a function, as well as state the equations of all asymptotes. We're going to have vertical and horizontal asymptotes this time. And then thirdly, describe the horizontal and vertical shifts, as well as stretches and shrinks without using a calculator. So just by looking at our equations, we'll be able to describe those. So this is in your book. You don't have to write this down. So what is a rational function? It's a function of this form, p of x over q of x, where p of x and q of x are both polynomials. Okay, so we've got two things divided by each other. The inverse variation function, which we've already talked about, this is a rational function. So the name of the shape of this is called a hyperbola. There's two symmetrical branches. We call them two symmetrical branches. And this shape right here, f of x equals 1 over x, this is our parent function for this. And you can see it goes right here through the point 1, 1, and right here through the point negative 1, negative 1. And that's what we'll use to see if there's stretches or shrinks. We'll compare to these 2 points right here. We also have a vertical asymptote right here of x equals 0, and a horizontal asymptote right here of y equals 0. So let's graph this parent function on our own. So we just talked about the horizontal and vertical asymptotes. So my horizontal asymptote, it's going to be right here, and that's the line y equals 0. So my range, that's all my possible y values, is all real numbers not equal to 0, because we could have anything but 0. My vertical asymptote is going to be right here, and that's the line x equals 0. So my domain, all the possible x's, are all real numbers not equal to 0. So let's make a table. We're getting pretty good at making these tables. The one difference here is I like to think, okay, where's my middle x? My middle x here is 0, so I need to make numbers around 0. So I'm going to use negative 1, negative 2, and negative 3. On the other side of 0, I'm going to use 1, 2, and 3. So I always like to think of where's my middle before I make my table. And if you plug this into your calculator, for negative 3, you get negative 1/3. This should be a 3. For negative 2, you get negative 1/2. For negative 1, you get negative 1. At 0, it's undefined. At 1, you get 1. At 2, you get 1/2. And at 3, you get 1/3. And if we graph these, negative 3, negative 1/3 is right about here. Negative 2, negative 1/2 is right about here. Negative 1 is right here. So we see there's no stretch or shrink there. 1, 1 is right about here. 2, 1/2 is right about here, and 3, 1/3 is right about here. So I'm just going to draw my hyperbola in here. And there's my graph. Okay, let's look at a little more complicated problem here. First of all, again, let's look at our horizontal and our vertical asymptotes. Now there's no movement for this, so my horizontal and vertical asymptotes are going to be the same. Here's my horizontal one, and that is the line y equals 0. So my range is all real numbers not equal to 0. Here is my vertical asymptote, and that is the line x equals 0. So my domain is all real numbers not equal to 0, since I can't have 0 for my x value. And looking at this, if you notice there's a negative 2 here. What that negative is going to do is it's going to reflect our hyperbolas over the x-axis. So we know we're going to have a reflection. We're going to reflect over the x-axis. Okay, and let's just kind of wait and see what happens to see if we have a stretch or not. And I can tell right now by looking at the equation, because I already know. My middle here is again going to be 0, so I'm going to use -1, -2, and -3, and 1, 2, and 3. And if you just plug those into your calculator, you get 2/3 for -3. For -2, you get 1. For -1, you get 2. For 0, you get for 1, you get -2. For 2, you get -1. And for 3, you get -2/3. And again, you should just be able to plug those into your calculator to find those values. So -3 2/3, it's going to be right about here. -2 1 is right about here. -1 2 is right here. And that has been stretched up. It doesn't go through -1 anymore. It's been stretched. And it's been stretched by 2. And you can see where that 2 is in the equation. Let's graph the other half of our hyperbola. So over 1 down 2, over 2 down 1, and over 3 down -2/3 is right here. And there's the other half. So if you notice right here, that 2 tells us we're going to have the stretch of 2. So we reflect it over the x-axis, and we have a stretch of 2, which you can see on your graph right here. If it was just a plain reflection, it would be right here, but we've also got that stretch. Let's graph another one, y equals 1 over 4x. Let's start by filling in our vertical horizontal asymptote, our range, and our domain. There's no movement here, so this is still going to be my horizontal asymptote, and that's the line y equals 0. So my range is all real numbers except or not equal to 0. This is going to be my vertical asymptote, and that is the line x equals 0. So my domain is all real numbers not equal to 0, because I can't have 0 for either of those. And looking at this, I can see right away 1 over 4. That's like 1/4. So I'm thinking I'm going to have a shrink of 1/4. Well, let's look and see at our table after we make that. So here's my table. My middle is going to have to be 0 again. I'm going to go -1, -2, -3, and then 1, 2, and 3. If you just plug these into your calculator, which I've already done, you get -1/12. For -3, for -2, you get -1/8. For -1, you get -1/4. For 1, you get 1/4. For 2, you get 1/8. And for 3, you get 1/12. So -3, -1/12 would be right about here, really close. -2, -1/8, still close. -1, -1/4 is still really close. So these are really close to our asymptotes here. So there's that half of the graph. I'm going to draw the other one over 1 up 1/4. Okay, now my parent function would have this at 1, 1. Since I went down to 1/4, I know I have a shrink of 1/4. And I don't have a reflection here. I just have that shrink of 1/4. So over 2, 1/8, and 3, 1/12. When they get so close, it's hard to draw them in there. I'm going to try and draw my branch really close to the axis. So there's my graph. Okay, so we're going to look at our translation rules for our rational functions here. So our translation rules, it looks just like the translation rules we've used before. You notice a -h next to the x and a +k here at the end. And this is going to move it just like you would think. A -h moves it to the right, and a +k moves it up. I'm sorry, a -h moves it to the left. It moves in the opposite direction that you would think, just like it always has. So let's try some of these. So looking here, I don't have anything at the very back. I don't have anything right here. I don't have a +k. So I know this doesn't move up or down, and since it doesn't move up or down, I can draw my asymptote in here. doesn't move up or down, so I know I've got this. That's a horizontal asymptote, so that's the line y equals 0. So I know for my range, it's all real numbers, not equal to 0. Looking here, I've got this minus 3, so I know my whole graph is going to shift to the right 3. So that would move my vertical asymptote over here to the line x equals 3. So my vertical asymptote is x equals 3. So that means the only x value I can't have is 3. So my domain is all real numbers not equal to 3. And you can also look at that this way. You can think, what would make the bottom of this 0? Well, if I plug positive 3 in here, 3 minus 3 is 0. So I know I can't have 3 in my domain, and my vertical asymptote has to be there at 3. That's just another way you can look at this. So let's make a table, just like we've been doing. And just like I've been doing, I'm going to think, okay, my middle has to be here at 3. So I'm going to use 2, 1, and 0. And on the other side, I'm going to use 4, 5, and 6. And I've already plugged these into my calculator. For 0, I get negative 1/3. For 1, I get negative 1/2. For 2, I get negative 1. For 4, I get 1. 5, I get 1/2. And for 6, I get 1/3. So I'm going to graph these now. 0, negative 1/3 would be, second, got to get a different color. 0, negative 1/3 would be right about here. 1, negative 1/2 would be right about here. And 2, negative 1 would be right here. So let me draw this branch in. And looking at this branch, I can see it goes right there through negative 1, 1, where it would be if I moved it over this way. So there is absolutely no stretch or no shrink for this graph. It's only got that vertical movement to the right. I'm sorry, horizontal movement to the right. Let me finish graphing this. 4, 1 is right here. 5, 1/2 is right here, and then the other one is off my graph. So I'm just going to draw in my branch right there. And I'm going to add my movement. To describe my movement, I could say I move to the right 3. And that's all I have to add. Let's look at the next one. Okay, so let's start by again looking at our equation to see what movements we've made. So this minus 2 says my whole graph goes down 2. I'm going to draw my horizontal asymptote right down here, down 2. So my horizontal asymptote is the line y equals negative 2. So for my range, I can have all real numbers not equal to negative 2. Right here I have plus 4. Plus 4 tells me that my graph moves to the left 4. So I'm going to draw to the left 4 right here as my vertical asymptote, and that's the line x equals negative 4. So I can have, for my domain, all real numbers not equal to negative 4. Let's make our table here. Okay, and the middle x value is going to be negative 4. So I need to do negative 3, negative 2, and negative 1. I'm doing this opposite actually, then negative 5, negative 6, and negative 7. I did that the opposite direction I usually do, but that's okay, not a big deal. So if I plug negative 1 in, I get negative 1.33. If you plug negative 2 in, you get 0. Negative 1 in, you get negative 3. Negative 5 you plug in, and you get negative 4. If you plug negative 6 in, you get negative 3. And if you plug negative 7 in, you get negative 2.67. So let's plot these points on our graph. So negative 1, negative 1.33 would be right about here. Negative 2, 0 would be right about here. And negative 3, negative 1 would be right about here. And something doesn't look quite right with my graph. If I plug, I plugged something in wrong here because it doesn't look right. Oh, I mixed these up. Okay, this should be the point, and you can notice here it doesn't look right because my graph isn't a hyperbola. So if you notice you're doing a problem and the shape of your graph doesn't look right, that should be a clue to you to say, uh-oh, I made a mistake somewhere. Let's figure out what mistake we made. And the mistake that I made here is just filling in my table. Actually, I probably just wrote it down wrong. I should have -2, -1, and I should have -3, 0. So -2, -1 would be right here. -3, 0 would be right here. So there's what my graph should look like. It's a good little lesson there. Make sure your graph looks right. And then on the other side of my graph, -5, -4 will be right about here. -6, -3 would be right about here, and we're pretty much off the graph, so I'm just going to draw this in here. So looking for my stretch or shrink, normally if this is where my asymptotes meet, my parent function would come right here. So I've got this stretch of 2. So to describe it, I'm going to say a stretch of 2. And then I also have to say that I moved left 4 and down 2. Okay, now we're going to look at just some other rational functions that you might see. Other rational functions, they can all be written in this form right here. Okay, y equals ax plus b over cx plus d. You can write them all like that. And the graphs are all hyperbolas. Here's the formula for the vertical asymptote. It's x equals the opposite of d over c. And we know this because the function's undefined when the denominator looks like this. When the denominator like this is 0, actually. And then your horizontal asymptote is this line, y equals a over c. So let's try one graph like this. Okay, so here's my graph. Remember the formula, or the form, the general form, like this, is y equals ax plus b over cx plus d. Okay, and to find our vertical asymptote is going to be x equals the opposite of d over c. Okay, so d in this case is 4, and c is 1. So this is 4 over 1, because d really right here is -4, so the opposite of d would be +4, and c here is just a 1, so 4 over 1 is 4. So my vertical asymptote is the line x equals 4. So let's put that graph on here. X equals 4 is right here. There's my line, x equals 4. My horizontal asymptote, well, that's the line y equals a over c. So a is right here, it's 3. C is 1. So 3 over 1. So my horizontal line, asymptote is the line y equals 3. So my range, I can have all real numbers not equal to 3. And my domain is all real numbers not equal to 4. And let's graph our horizontal asymptote. That's the line y equals 3. So it comes right here. Okay, well, let's now make our table. We're going to do our table the exact same way that we've been doing. Find your middle first, and since x equals 4 is my middle, I'm going to use 4 as my middle x value. So I need to do 3 and 2 and 1. And on the other side, I need to do 5 and 6 and 7. And I've already plugged these in. And I know for 1, it's negative 1.33. For 2, it's negative 3.5. For 3, it's negative 10. For 5, it's 16. For 6, it's 9.5. And for 7, it's 7.33. So let's plot those points on our graph. 1, negative 1 1/3 would be right about here. 2, negative 3.5, 1, 2, 3.5 would be right about here. And then 3, negative 10 would be off my graph. Okay, so I'm going to draw my points in, draw my curve in here. 3, negative 10 would be way down here. Okay, and then 5, 16 is going to be way up here, way up at the top. And 6, 9.5 is going to be a little bit further down here, so my other half is going to be up here in the corner. And I really ran out of space. You should be able to graph them a little better on yours probably. But you have the same graphs as I do. So to describe this, we're going to just say this goes right. It goes right 4. And it goes up 3. And that is the end of these notes. If you have any questions, make sure you starred them so that we can go over them in class tomorrow. And have a great day.